Hi, I'm JD, and in this lecture, we're going to go over the addition and subtraction of fractions, and then we're also going to solve simple linear equations. So here's a little preview of what we're going to be going over. Addition and subtraction of fractions. Second, we're going to go over operations with mixed numbers, maybe little fractions thrown in there too. Three, we're going to look at applications of fractions and mixed numbers. And then lastly, we're going to look at solving linear equations, which is a building up of things that we learned in Unit 1 and Unit 2. So first, let's look at adding and subtracting fractions. So step number one is to find the LCD. LCD stands for least common denominator. This is also the least common multiple. And multiples of 2 would be 2, 4, 6, 8, 10, etc. Multiples of 3 would be 3, 6, 9, 12, 15, 18, 21. So to find a multiple, you just take whatever the number is and multiply it by the natural number. So multiples of 3 would be 1 times 3, which is 3, 2 times 3, which is 6, 3 times 3, which is 9, 4 times 3, which is 12, etc. And when you're finding a common multiple, you're looking at both of those and you're saying, okay, what do they have in common? And I'll show you a way that you can easily find the LCD. The reason why we need to find the LCD is because we need to make the denominators the same. So use equivalent fractions. Whatever you multiply to the bottom, you multiply to the top. Step number 3 is to add or subtract the numerators together. Before you do step 3, you have to do steps 1 and 2 if the denominators are different. If the denominators are the same, you can skip step 1 and step 2 and just do step 3. And we'll look at examples of that. And then step 4 is basically simplify if needed. If it's saying to simplify, you always want to double check at the end to see if you can simplify it. And notice that there's no simplification in the in-between steps here because you're adding or subtracting. There's only cancellation or simplification in between steps when you're adding and subtracting, when you're multiplying or dividing fractions, what we saw last unit. So now let's look at some examples. We'll start off with addition, and then we'll move from that to subtraction. We'll look at some mixed numbers and some others. So let's start with adding. So here the directions state to add and simplify. So part A, or letter A, you have 2 over 6 plus 5 over 6. So you would add the numerators together and keep the denominator the same. So that'd be 7 over 6. You can kind of think of the denominator kind of like terms. When you have like terms and you're combining them, you add or subtract what's in front. Here the numerators act like that, and then 6 is kind of like that, and the denominator is kind of like that like term. So you have 2 plus 5, which is 7. 6 stays the same. That's an improper fraction. Sometimes it might ask you, or sometimes you can leave it as an improper fraction, but sometimes it might tell you to put the result as a mixed number. So 6 goes into 7 once with a remainder of 1. So to write as a mixed number would be 1 and 1 over 6. Now let's look at letter B. You have 3 twelfths plus 5 twelfths. So you would add the numerators. So that gives you 8. So it'd be 8 twelfths. You can simplify that. So you would want to. If I look at 8 and 12, it looks like 4 goes into both of them. 4 goes into 8 twice. 4 goes into 12 3 times. So that'd be 2/3. And that's it. Here's another example. And we're to add and simplify. So I have 5/12 plus 4/15. The denominators are different. So what I have to do here is I have to find the LCD and use equivalent fractions. So with LCD, you're focusing on the denominators. So you use 12 and 15. I like this Venn diagram method. So with this method, what goes in the middle here is what they have in common. So the GCF of 12 and 15 would be 3 because that's the largest number that goes into 12 and 15 evenly, meaning no remainder. And then what goes here and there would be whatever makes that top number. So what times 3 will give you 12? 4. What times 3 will give you 15? 5. Now, the GCF is 3. The LCD is what they have in common and what they don't have in common, which is what we just found. So you just multiply these. So 4 times 3 is 12, times 5 gives you 60. So 60 is our LCD. I want to make these denominators 60. So to make 12 60, you would multiply it by 5. So here you're going to multiply the top and the bottom by 5 to that first fraction. To that second fraction, you want 15 to become 60, so you multiply 15 by 4. And so you would do the same thing to the top. So 5 times 5 is 25. 5 times 12 is 60. 4 times 4 is 16. 4 times 15 is 60. So we have 25 over 60 plus 16 over 60. Add the numerators together, keeping the denominators the same. You might be tempted to simplify in this step, but when it comes to addition and subtraction, you want to simplify in the last step. So 25 plus 16 is 41, so that's 41 over 60. So it looks like they have nothing in common, so you would be done, except for one, of course, but that's irrelevant when you're simplifying fractions. So, all right, so now let's move to subtraction. So here the directions say subtract and simplify. Subtraction is very similar to addition. So you just subtract the numerators. Sometimes you might have to make a little bit of adjustments when you're subtracting, kind of differently from when you're adding. And we'll go over that. So 11 over 18 minus 4 over 18 gives you 7/18. 13 over 21 minus 4 over 21. Subtract the numerators, so 13 minus 4 is 9, so it's 9 over 21. We can simplify that. 3 goes into both of those. So 3 goes into 9 3 times. 3 goes into 21 7 times. So that's 3 over 7. Oh. So, all right. So here with the mixed numbers, when you're adding, what you want to do is you want to add the whole numbers separately and add the fraction separately. So 1 plus 3 equals 4. 2 over 8 plus 3 over 8 equals 5/8. So we get 4 and 5/8. You would see if you can simplify the fraction, but you can't. And you wouldn't simplify the whole number because this is not multiplication. 4 and 5/8 is a plus, so you would just leave it this way. All right, so let's look at an example when we're adding mixed numbers and where the denominators are different. So here, when the denominators are different, it's best to use equivalent fractions. And it's also best when you're adding and subtracting mixed numbers to not put them as improper fractions, because you don't need to. And when you're doing equivalent fractions with an improper fraction, especially these, you're going to end up with very large numbers. And so it's easier just to leave these as mixed numbers. So let's find the LCD first. So 6 and 8, use the Venn diagram method. Again, what goes in the center right here is the GCF, which 6 and 8, they're both even, so the GCF is 2. Over here, what goes here is what times 2 will give you 6, which is 3. What times 2 will give you 8, which is 4. Multiply these, so 3 times 2, which is 6, times 4 is 24. We're going to use equivalent fractions here. So with that first fraction, 5/6, I'm going to multiply the top and the bottom by 4. And then with that second fraction, I want to make 8/24, so I'd multiply the top and the bottom by 3. So I get 10 and 20/24 plus 7, 9/24. Now, as before, when you're doing mixed numbers, add the whole numbers together, add the fractions together. So 10 plus 7 is 17. 20/24 plus 9/24 gives you 29/24. So you have 17 and 29/24. Now, 29/24 looks kind of weird. And the reason for that is because it's an improper fraction. And when it comes to mixed numbers, this fraction cannot be an improper fraction. So you have to change it. So to do that, take 24. See how many times does 24 go into 29? Goes into it once with a remainder of 5. And you would add that one to the whole numbers. So that would be 17 plus 1, which is 18. And the remainder stays over the denominator. So that'd be 18 and 5/24. All right, now let's look at an example when you're subtracting mixed numbers. So notice here that there's no fraction. So what I'm going to have to do is take one whole from that 12. That makes it 11 and 8/8. Because you don't want to do this because it's almost like 0 minus 3/8. So you want to borrow, kind of like when you're borrowing from when you're doing other addition and subtraction things. You're borrowing here, but here you're borrowing one whole. And notice that 8/8 is the same as 1. So I'm not really changing anything, I'm just changing the way it looks. And then you would subtract the wholes and subtract the fractions. So 11 minus 9 is 2. 8/8 minus 3/8 gives you 5/8. So your answer is 2 and 5/8. Nothing simplifies here, so you're done. All right, so let's look at another example. And with this example, we're going to look at fractions and using the order of operations. So just a reminder of what the order of operations are. You have parentheses and then exponents. and then multiplication or division from left to right, and then addition or subtraction from left to right. So notice here that there is no parentheses, there is no exponents. So then what you would do is multiplication or division from left to right. But division comes first, so we'll do keep it, change it, flip it, and that changes it to multiplication. When you're multiplying fractions together, you multiply across. So numerator with numerator, denominator with denominator. So 2 times 2 is 4, 3 times 1 is 3. So that ends up with 4/3. Notice the 4 and the 8, we can cancel out before we multiply, right? We can either cancel within the same fraction or diagonally. When we're multiplying, we can cancel out the 4 and the 8 here. So 4 goes in 4 once. 4 goes into 8 twice. So that leaves me with 1/3 times 5/2. Multiply across, so 1 times 5 is 5. 3 times 2 is 6. So that leaves me with 5/6. So now I have just addition. So 1/6 plus 5/6 gives me 6/6. I can simplify that further because that fraction bar is the same as division. So 6 divided by 6 is the same as 1. So my final answer is just 1. And 1 would be more simplified. You might ask, okay, if I compare an improper fraction to a mixed number, which one's more simplified? It just depends what they're asking for when it comes to that. But if you can make it into just one whole number, you would want to do that, and that would be simplified. All right, now let's look at a couple of application problems. So the length of a rectangular cornfield is 15/16 of a mile. The width is 5/8 of a mile. What is the area of the cornfields? So here are some keywords. Rectangular, which means that it's the shape of a rectangle. And then also what you're looking for is area. So you need to know the area of a rectangle formula, which is area equals length times width. Now you're given that specifically what the length is and what the width is, so you would plug those in. So the length is 15/16 and the width is 5/8. Now you would see if you're able to cancel anything out or simplify it by looking either within the same fraction or diagonally. And here there's nothing that you can simplify, so you would just multiply across. So 15 times 5 is 75. 16 times 8 is 128. Now, since nothing's simplified before you multiply it, nothing's going to simplify after you multiply it. Unless it was an improper fraction, they want it as a mixed number. But nothing's going to simplify. So that's your answer, 75/128. Now the units for that, since it's area, it's going to be square units. Sometimes you might see it as miles squared. And in some cases, usually you would type in the number separately, and they might have you select the units. Or just type in the number, depending on what they're asking for in ALEKS. Another application problem. I'm going to read it. Perfection Cable has 2 crews who install internet communication cable. Crew A can install 38 1/8 feet per hour, crew B can install 31 and 2/3 feet per hour. How many fewer feet can crew B install per hour than crew A? So it's a comparison problem, and here's a key word: fewer. So that fewer is telling you to subtract. You need to find the difference between these two values. And you know that crew B installs less because it says how many fewer feet can crew B install compared to crew A. So you would subtract these. So 38 and 1/8 minus 31 and 2/3. You find equivalent fractions. So if I look at 8 and 3, their GCF is 1. So when that's the case, you can multiply those two numbers together and get the LCD, which here is 24. 8 times 3 is 24. Notice with that first fraction, to get from 8 to 24, you multiply by 3. So there you would multiply the top and the bottom by 3. With 2/3, with that 3, you need to make that 24. So you would multiply the top and the bottom by 8. Now at this point, don't change it to do not change it to an improper fraction. Keep them as mixed numbers. Subtract the wholes. So 38 minus 31 is 7. And notice with the fractions, you have 3 over 24 minus 16 over 24. So maybe I need to hold back a little bit, because 3 over 24 minus 16 over 24 gives me a negative number. And that's a big no-no. What you're going to do is you need to borrow from the wholes place. So we're going to take that 38, borrow from there, make that 37. We're borrowing one whole, and one whole is made up of 24 parts for this fraction. So I'd add 24 to 3, which makes it 27. And now I can subtract. So 27 minus 16 over 24 is 11/24, and then 37 minus 31 is 6. So it gives me 6 and 11/24. That doesn't simplify, so that's my answer. So 6 and 11/24 feet fewer. Now let's look at linear equations. So your goal with solving linear equations, which is linear equations or one variable equations, is the most basic equation there is. And it's good to master these. It's going to be very helpful when you get to college algebra. So your goal is to get the variable all by itself. And here are the steps. Now these steps are optional depending upon what you have. So, but this is kind of, I guess you can say, the general strategy or the general flow of how you're going to approach linear equations. So step 1 is you want to simplify both sides. And notice with this, with simplifying both sides, you have a left side and a right side. So you look at the left side separately, combining like terms, and then the right side separately, combine like terms, simplify it as much as you possibly can. Step 2, add or subtract both sides to get all the variables to one side and all your constants to the other side. Then step 3, and this is kind of what we saw last week. So you can either do one or two things. You can either divide both sides by the coefficient, that is the number in front of the variable, or you can multiply both sides by the reciprocal. And then step 4 is to verify the solution. To verify the solution, you would plug it in. Now, key questions to ask yourself while you're doing this: what am I solving for? So you're solving for x, you're trying to get that by itself. What operation is being done? So if it's subtraction, and then how do I undo that? So if it's subtraction, that's why you want to ask that second question. Look what's there, so minus sign. How do I undo that? The opposite of subtracting would be adding. Now let's go through some examples. All right, we're going to start easy, and we're going to go to some more interesting problems. So we have 3x plus 4 equals negative 11. I'm trying to get x by itself, so I have 3x plus 4. I want to get rid of the 4, so I'm going to do the opposite. So I'm going to subtract 4 from both sides. When I do that, plus 4 and minus 4, that's going to cancel. And then negative 11 minus 4, that gives me negative 15. So it gives me 3x, because the plus 4 minus 4, that cancels out to just plus 0. We saw that. 3x plus 0 is just 3x. Now I have 3x equals negative 15. That 3 in the x is multiplication, so I do the opposite of multiplication, which would be division. So I divide both sides by 3. 3's cancel on the left-hand side, leaving me with just x, and negative 15 over 3 gives me negative 5. So x equals negative 5. And at this point, you would plug it into the original problem to check your answer. And if it makes a true statement, which it does, that means you did everything correctly. All right, a little bit more complicated example. So first, let's combine like terms. So if I look at the left-hand side, those x's can be combined. So 8x plus 7x equals 15x. That leaves me with 15x minus 3. On the right-hand side, the 25 and the plus 2 can be combined. So 25 plus 2 is 27. Now, when you're combining like terms, just take the sign of whatever's in front of it. So I have 15x minus 3 equals 27 minus 15x. Now, at this point, what you can do is you can either add or subtract the variables and add, subtract the numbers, or you can do them at the same time. So if I want to move my x's to the left-hand side, I need to get rid of that minus 15x. So I'd add 15x to both sides. And if I want to get rid of that minus 3, I can add 3 to both sides. And I can do this at the same time when I'm adding or subtracting. So notice, so you have 15x plus 15x, that's 30x. The minus 3 plus 3 cancels, so I'm left with just 30x on that side. And then on the other side, 27 plus 3 is 30, minus 15x plus 15x, that cancels, leaving me with 0. So it's 30 plus 0, which is just 30. At this point, I have 30x, which is the same as whenever you have a number right next to a variable, that's the same as multiplication. So you would divide both sides by 30. So 30 over 30 is just 1, so that's 1x, which is just x, and then 30 over 30 is just 1. So here's a here's a doozy. Now, what if you have fractions? Now, like I said, that those steps before are general steps or kind of like a flow if necessary type thing. Now, if you have fractions, what you can do is you can multiply both sides first. And since there's addition and subtraction, it's basically a distributive property. So if I multiply both sides by the LCD, which here is 6, multiply by the LCD, which is 6, then things are going to cancel out. If need be, you can write that 6 as 6 over 1, if that makes things easier for you. But if I multiply 6 times 2/3, multiply across, so that'd be 6 times 2, which is 12. 12 over 3 gives you 4. So that's 4x. 6 times 1 over 6, when multiplying, is 6 over 6, which is just 1. 6 times 1/2, that would be 6 over 2, which gives you 3, so that'd be 3x. On the other side, you have 6 times 7 over 6. Now, if you want, you can cancel things first. So with those 6's, those would cancel, just leaving you with 7. And then you have 6 times 2x, which is 12x. Now, once you do this, all those fractions go away, and you wouldn't have to see fractions until the very last step. So this makes it a little bit easier. So then you would combine like terms or simplify both sides. 4x plus 3x, those combine, giving you 7x. Again, you can do the same thing that we did in the last problem, is do all your adding and subtracting of terms at, your terms and your constants at the same time. So I like having my x's on the left-hand side, so I would subtract both sides by 12x. In the same breath, I can add 1, doing the opposite of subtracting 1. Can add 1 to both sides. That's going to leave me with negative 5x equals 8. And then I would divide, because it's negative 5 times x, times opposite of multiplication would be division. So I can divide both sides by negative 5. So that gives me x equals negative 8/5. I could have left it as 8 over negative 5, and that would be the same as that negative 8/5, because when it's negative like this, you can place the negative either in the numerator on the side or the denominator, and it's the same. And then what you would do is take negative 8, so you need to verify it. Take negative 8/5 and plug it into the original problem. That's easier said than done, but when you're doing linear equations, the verification is kind of optional, where you don't need to do it when you have other equations. When it comes to college algebra, there's times where you do have to verify it. I would just learn how to verify it using a calculator. And that's it. So we went over addition and subtraction of fractions. It's a little bit more complicated than multiplying or dividing of fractions. Sometimes you have to find equivalent fractions and, using the LCD. And then all the simplification is at the end. We looked at operations with mixed numbers. When it comes to adding and subtracting of mixed numbers, we did not change them to improper fractions. So we just focused on the wholes and the fractions. When you're subtracting, you want to focus on subtracting the fractions first. So sometimes you might have to borrow, and then subtract the wholes and subtract the fractions. Then we looked at applications of fractions and mixed numbers. You want to look for keywords that would indicate what operation that you need to do with the fractions that are in the problem. And then we looked at solving linear equations. And in this chapter, we combine the two properties of equality, the addition property of equality and the multiplication property of equality, combine those two to solve equations, linear equations in general. That concludes this video. If you have any questions, put them in the comments below. Also, please like, share, and subscribe. Thank you, and I hope you have a wonderful weekend.